Have you ever wondered how wireless networks work? Picture this. You're sitting in your favorite coffee shop, laptop open, and you're surfing the web without a single wire in sight. This is the beauty of wireless networks. They allow our devices, from laptops to smartphones, to connect to the internet without the need for physical wires or cables. Imagine a world where we're bound by the length of a cord. It's hard to even think about, right? That's because wireless networks have revolutionized the way we interact with the world around us. They've provided us with a level of convenience and flexibility that was unimaginable just a few decades ago. Whether we're at home, in the office, or even in the middle of a park, wireless networks ensure we're always connected, always online, and always ready to engage with the digital world. So, stay tuned as we delve deeper into the fascinating world of wireless networks. So, how do these invisible networks actually operate? Well, think about when you tune into your favorite radio station. You can't see the music floating towards your car, right? That's because it's being transmitted over the air through radio waves. The same principle applies to wireless networks. They use radio waves to transmit data across devices. Imagine radio waves as a bustling highway, where data packets are the vehicles traveling back and forth. This highway is unseen to the naked eye, but it's continuously active, facilitating the exchange of information at lightning-fast speeds. Now let's talk about the key players that enable these wireless networks: routers and access points. Routers are like the traffic controllers of this highway. They determine the best route for the data packets to reach their destination quickly and efficiently. They connect multiple devices, either wired or wirelessly, and allow them to communicate with each other and with other networks. But how do devices connect to the router wirelessly? That's where access points step in. Access points are like the on-ramps to our highway. They allow devices to connect to the network wirelessly. When you connect your smartphone to your home Wi-Fi, for instance, you are likely connecting to an access point. It takes the wired internet connection and converts it into a wireless signal that your phone can use. There's a symphony of data transmission happening every time you stream a video, send an email, or play an online game. Every bit of data is routed through this invisible highway, directed by the router, and delivered to your device through the access point. It's important to remember that while this process may seem complex, it's happening in the blink of an eye. This seamless operation is what makes wireless networks so powerful and integral to our daily lives. Now that we know how wireless networks operate, let's explore the different types of wireless networks. Did you know there are different types of wireless networks? Yes, indeed. Today we're going to delve into the three main types of wireless networks: Personal Area Network, PAN, Local Area Network, LAN, and Wide Area Network, WAN. Let's start with the Personal Area Network, or PAN for short. This is the smallest type of network, typically used for connecting devices located within a range of 10 meters. Imagine you're at home, listening to your favorite podcast on your smartphone, and you want to connect your wireless headphones. That's a perfect example of a PAN. In essence, it's a network that allows devices in immediate proximity to communicate wirelessly. Next, we have the Local Area Network, or LAN. This network is larger than a PAN and is commonly used in offices, schools, or homes. It allows devices to connect within a certain area, usually within a building or a group of buildings. So, when you're at school and you connect your laptop to the school's Wi-Fi, you're using a LAN. Finally, we have the Wide Area Network, or WAN. This is the largest type of network and can cover areas from a city to an entire country or even the globe. The internet is the most common example of a WAN. It allows you to connect to a server located halfway across the world, send emails, and surf the web. Each of these networks has its own unique range and use. A PAN is great for personal use. A LAN is perfect for connecting devices in a small area like an office or school, and a WAN is ideal for large-scale connectivity. Understanding these networks is important as it can help us choose the appropriate network for our needs. For instance, if you're setting up a home office, you might want to consider setting up a LAN. On the other hand, if you're a tech giant looking to connect offices across the globe, a WAN would be more suitable. Understanding the different types of wireless networks can help us choose the right network for our needs. So next time you're connecting to a network, take a moment to appreciate the type of wireless network you're using. Ever heard of the term access point? Let's find out what it means. An access point, often abbreviated as AP, is a device that allows wireless devices to connect to a network. It's like a bridge that connects wireless devices to a wired network, typically an Ethernet network. The access point uses radio frequencies or Wi-Fi to connect wireless devices and to send and receive data from them. Access points are especially useful in extending the wireless coverage of a network. Let's say you have a large house or an office with multiple floors. Your wireless router might not be able to cover the entire area. This is where access points come in. By strategically placing access points around the building, you can ensure that the Wi-Fi signal reaches all corners. Now you might be wondering, isn't that what a wireless router does? Well, yes and no. While a wireless router does provide a Wi-Fi signal, it also performs a lot of other functions. For instance, it connects your home network to the internet, assigns IP addresses to your devices, and provides firewall protection. An access point, on the other hand, focuses solely on creating a wireless network. It doesn't connect to the internet or assign IP addresses. It simply takes the wired internet connection from your router and turns it into a wireless one. So if you're experiencing dead zones in your Wi-Fi coverage, an access point might be just what you need. It's a cost-effective and efficient way to extend your Wi-Fi coverage without overburdening your wireless router. And that's not all. Access points can also handle more simultaneous connections than a typical wireless router. This makes them perfect for environments with a high density of wireless users, like cafes, airports, or large offices. In summary, while your wireless router is the heart of your home network, access points are the arteries, extending the network's reach and ensuring every device gets a strong, stable connection. Access points are crucial in maintaining strong and stable wireless connections. Access points come in different types, each with its own set of features. Let's dive into the world of access points and explore the various types available. Firstly, there are standalone access points. These are the most basic form of access points. They work independently and are not connected to any central system. Standalone access points are ideal for small networks or for extending the range of an existing network. They are simple to set up and relatively inexpensive. However, they may lack advanced features and might not be the best choice for larger networks. Next up are controller-based access points. These access points are connected to a central controller that manages their functionality. This allows for greater control over the network, as changes can be made centrally and pushed out to all access points simultaneously. This makes them ideal for larger networks or environments that require high levels of security and control. However, they can be more complex to set up and typically come with a higher price tag. Lastly, we have cloud-based access points. These are the newest type of access points, and they offer a balance between standalone and controller-based access points. Cloud-based access points are managed via the cloud, which means they can be controlled from anywhere with an internet connection. This offers great flexibility and scalability. They are ideal for businesses or organizations that have multiple locations, as they can all be managed from a single point. However, they rely on a stable internet connection for management and can be more expensive than standalone access points. Each type of access point has its own benefits and drawbacks. Standalone access points are simple and affordable. Controller-based access points offer high levels of control and security, and cloud-based access points provide flexibility and scalability. The choice depends largely on the specific needs and constraints of your wireless network. Choosing the right type of access point can significantly improve your wireless network experience. So, take your time, weigh the pros and cons, and choose the one that fits your requirements the best. Remember, the right tools can make all the difference in the world of wireless networks. Let's quickly recap what we've learned today. We started our journey by understanding the concept of wireless networks. These invisible highways, which allow us to connect to the internet without any physical connection, are an integral part of our everyday lives. We then delved into the workings of these networks, understanding the intricate process by which data is transmitted through the air, from one device to another. We also explored the different types of wireless networks, each with its unique characteristics and uses. From personal area networks that connect your devices in close proximity, to wide area networks that cover large geographical areas, the range is vast and diverse. Our conversation wouldn't have been complete without discussing access points. These are the bridges that connect your device to the wireless network. And just like wireless networks, access points also come in various types, each designed for specific needs and environments. The next time you connect to a wireless network, remember the complex yet fascinating technology behind it. Until next time.